Okay, calculus, let's continue 12.4. So the tangent line to a curve at a point is the line that passes through the point and is parallel to the unit tangent vector. So in the next example, we'll find the unit tangent vector and then add that vector to our starting point to get a tangent line at a point on a helix. So find t of t, and then find a set of parametric equations for the tangent line to the helix given by r of t equals 2 cosine ti plus 2 sine tj plus tk at the point root 2 pi over 4. The first thing we need to do is find t of t, which is r prime of t over the length of r prime of t. R prime of t is just the derivative, so we've got r prime of t is the derivative, I think the derivative of 2 cosine t is negative 2 sine ti plus 2 cosine tj plus just k. If we were to look at the length, this is v of t, of course. The length of v of t, square root, we square all of these except for the I, j, and k. They don't go in there. Be 4 sine squared t plus 4 cosine squared t plus 1. Sine squared plus cosine squared is 1, so this is just 4 plus 1, which is square root of 5. Now, I need to take my t of t takes all of these terms and divides them by the square root of 5. So negative 2 over square root of 5 sine ti plus 2 over square root of 5 cosine tj plus 1 over square root of 5 k. Now it wants to know about the tangent at pi over 4. So pi over 4 is the time in which this happens. Why? Because we know t is equal to z here. So when we plug in pi over 4, what do we know about sine of pi over 4 and cosine of pi over 4? Both of them are root 2 over 2. So that means the 2's will, so we have negative 2 over root 5 times root 2 over 2 plus 2 over root 5 times root 2 over 2 plus 1 over root 5. Now when we simplify, that means t pi over 4 is the 2's will cancel, so we have negative root 2 over root 5, which should be I still, j and k, I don't know why I left those off, I plus root 2 over root 5 j plus 1 over root 5 k. Now this gives us the tangent vector at pi over 4. But remember, it has to be going through the point. So what we need to do is start it at a different value. So the x term of our point is root 2. And then we have minus root 2 over root 5 times, we'll call it s, where s is a function of t. We don't really know exactly where it's starting. Y is root 2 plus root 2 over root 5s. Z is pi over 4 plus 1 over root 5s. And what is s? S is this vector that we just came up with. The I, j, and k. It's the unit vector we came up with. It's just, we don't know exactly when it's happening. We know the motion is going to be, but we don't really know how it's going to behave relative to time. So this gives us the 3 components of our tangent line. Now one thing to note technically, there are infinitely many vectors that are orthogonal to the tangent vector due to being in a 3D space. The derivative vector is just 1. By normalizing the vector t prime of t, you obtain a special vector called the principal unit normal vector, indicated in the next definition down below. If C is a smooth curve, represented by r, and t prime of t is not 0, and the principal unit normal vector is t prime of t over the magnitude of t prime of t. So how can we use this? Find n of t and n of 1 for the curve represented by r of t equals 3ti plus 2t squared j. So t of t is v of t over the length of v of t. So v of t, our derivative, is 3i plus 4tj. The length of v of t, square root of 9 plus 16t squared by squaring both of these. So that means t of t equals 3i plus 4tj over the square root of 9 plus 16t squared. And we can find this derivative by using our old school quotient rule, low d high, times the derivative of the top. 3 is a constant, so that means it's gone, but 4tj will just be 4j, minus high d low, 3i plus 4tj, times the derivative of the bottom, which is 1/2, times 9 plus 16t squared to the negative 1/2, times the derivative of the inside, which is 32t. And then divided by the denominator squared, which is just 9 plus 16t squared. So if we clean this all up, okay, let's think about our I terms. Let's collect all the I terms. There's 32t, negative 32t times negative 3i times 1/2. So that's 96 times 1/2. It looks like negative 96 times 1/2, so that's negative 48t divided by this to the 1/2 times this, which makes a total of 9 plus 16t squared to the 3/2. Now let's collect all of our j terms. We know we've got a 4 times 9 plus 16t squared under the square root over the denominator. And we also have a j term on the right side, which ends up being minus 64t squared over 9 plus 16t squared to the 3/2. All this is j. We can clean this up by multiplying this by 9 plus 16t squared to the 1/2. It'll clean up the top, get rid of the square root, and it will make us have a common denominator here. And it simplifies to negative 48t over 9 plus 16t squared to the 3/2 I, plus it ends up being 36 over 9 plus 16t squared to the 3/2 j. And that is our normal vector, and we can plug in 1 to see what would happen. So at 1, it's negative 48 over, this ends up being 25 to the 3/2, which is 125, and then I, and then plus 36 over 125j.